factoring piece. Let's see how it goes. So notes, probably a calculator. I would definitely get a calculator. Notes and a calculator, notes and a calculator. So all right. So let's talk about the number one when we're factoring. What's the first thing that we should always do? Yeah, make sure it's in standard form. I'm just going to abbreviate that STD form. Okay. What else? Look for what? What are we supposed to do next? Look for a greatest common factor, or GCF. We need to do those first. So when I look at number one, we'll do half of these. When I look at number one, I see that it's in standard form, but I need to figure out if there is a greatest common factor. So if you don't remember your math facts, what you can do is go to your calculator and type in under y equals 18 divided by x. That would be the y equal 1 column. Y equal 2, type in negative 210 divided by x. And y3, type in 432 divided by x. We are looking for a common factor. And we want to find the biggest one, the biggest number that divides both of those. We want to find the biggest number that divides both of those numbers. I'm trying to pull up the hover cam just so you can see it. But you know what? Maybe I'll just use Desmos because that's not working for me. Yeah, it is 6, but I want to show everyone how to see it. I'm going to go to just Desmos graphing calculator. So when you're taking your test, you can just type in right here 18 divided by x, and then you hit the gearbox. We should do y equals, sorry. Y equals 18 divided by x. If you hit this little gear wheel, do you guys remember that this will give you a table of values? It'll give you a table. So we've talked about this before. If you need more numbers in your table, Hayden, will you jump up there and erase the 18, like what I just wrote over there? There are more numbers in your table, but you just have to like request them. If you just go to your table and start hitting enter, it'll populate as many numbers as you want. Right? So these are all the numbers that divide 18. Let's look at all the numbers that divide negative 210. So y equals negative 210 divided by x. And I'm going to do that same thing. I'm going to hit the gear and I want the table of values for that. And I'm going to go to the inputs and just plop out some more. And then I'm going to go to y equals 72 by x. Well, oh no, it's not 72. Sorry, it's 72 after we divide by 6. Y equals 432 divided by x. And then again, I'm going to hit the wheel up here, the gear, and I'm going to get a table of values, and I'm going to just populate it a little bit. So if they have decimals, are they divisible by that number? No. So let's see. 6 divides 18. 6 will go into 18 3 times. 6 divides 210 35 times. And 6 divides 432 72 times. If you have it in your calculator, you can kind of see them all lined up, but that's exactly what you're needing to do. You're trying to find the greatest common factor. So a number that divides them all. So we are going to divide everything by 6. So I'm going to put the 6 down here and draw an answer blank because I don't want to forget about it. Sometimes when I take out a greatest common factor, I forget what it was. So 18 divided by 6, that's 3. So I have 3 n squared. 210, negative 210 divided by 6, well, that was negative 35 n. And 432 divided by 6 is a positive 72. So now I need to look at making a times plus chart. So remember, we are taking the first term times the last term, and it has to sum up to the middle term. So I have to figure out what 3 times 72 is. That's what's going right here in this blank. What number is that? Hello, you guys have calculators. 3 times 72. 216. So I need to find numbers that multiply up to 216 and add up to negative 35. So again, in your calculator, you're going to go to y equals 216. Y equals 216. And because you need a negative number, I guarantee you that your factors are going to be negative, right? So y equals, clear all that out of there. So 216 divided by x. I see your hand, honey. And then I'm going to go to the second graph, right? Second graph. And here is your table of values. You guys have to know how to do this. We know that our factors are going to be negative. So I'm looking for two numbers that I can multiply together to get 216, that when I add them, give me a negative 35. Yeah, right there. Negative 27 and negative 8. Negative 27 and negative 8. So my two factors are going to be negative 27 and negative 8. So my leading coefficient is not 1. That means I have to factor these by grouping. So I have 3n squared minus 27n minus 8n plus 72. All we're doing when we factor by grouping is we are taking this term right here and breaking it up into two terms. Negative 27 and negative 8 give you the negative 35. We're just doing that so we have 4 terms. 4 terms lets us make 2 what? 4 terms lets us make 2 what? Yeah, 2 groupings. Okay, so what's the greatest common factor here? 3n. So when I pull a 3n out of that first parenthesis, I'm left with n minus 9. What's the greatest common factor here? It's negative 8. When I pull out a negative 8, I'm left with n minus 9. And we need to have this right here. What is this called? What is n minus 9 called? Mrs. Bischoff. I actually sent him to the office as soon as I came in this morning. I wrote him a pass to go see, I sent him to the main office, and I spoke to Mary Elaine on the phone. And then I tried calling Mr. Sorolix. Are you talking about Zach Brock? Oh, okay. Yes, I do. I'll send him down. All right. Thanks, hon. Bye-bye. Yeah. Okay, so after instruction, you can do that. Okay. It'll be fine. Zach, you're going down to the office. Sorry. 8. No. There you go, hon. Okay. So what is this repeated term called? I did start the video. Can someone answer this for me? What is the repeated term called? It's the copycat. We need this n minus 9, right? We need that. That's our first term. N minus 9. 3n minus 8. Okay, so that is what our final answer is. We have got to know how to factor, okay? We have got to know how to factor. We spent weeks, like actually months on factoring. Okay? So let's go ahead and do number 3, and then we'll do number 6. So I'm going to jump down to number 3. So number 3, do we have a greatest common factor? Let's see, they're even. Everything's even, so that means it's divisible by 2. But is it divisible by something bigger? Like, is it divisible by 4? Can we try dividing everything by 4? Does that work? Yeah, it does. All of these are divisible by 4. 36 divided by 4 is 9. That gives me 9a squared. 200 divided by 4, that's negative 50a. And negative 96 divided by 4 is negative 24. So I need to think about what two numbers multiply together to equal, what is my first term times my last term? What is this term times this? A times C. Yes, negative 216. And it adds to negative 50. And I'm just going to tell you what those numbers are. They are negative 54 and positive 4. Those are my two numbers. Negative 54 times 4 is negative 216. Negative 54 plus 4 is negative 50. So factor by grouping. 9a squared minus 54a plus 4a minus 24. Again, all I'm doing is taking this term and breaking it up into two terms. Negative 54 and a positive 4 give me negative 50. So I didn't change the problem. I just changed the way it looks because I need to have two sets of parentheses. I need to have 4 numbers so I can break them up into sets of 2. Okay. So let's factor this. Let's see. I can divide by 9a for the first parenthesis and by 4 on the second one. So when I take out a 9a, I'm left with a minus 6. And when I take out a positive 4 for the second one, I'm left with a minus 6. Do I have a copycat? Yeah, it's a minus 6. That's going to come first. What do I have left over? 9a plus 4. Okay. It is really, really, really super important that we know how to factor. Okay. So I want everyone to look at number 6 and tell me what you think you can take out of 6. What is the greatest common factor? For number 6, what is the greatest common factor? I don't think 78 is divisible by 4. What? They're all even, right? Yeah. Number 6. You think 6? 20 isn't divisible by 3. 20 is not divisible by 6, right? So it's going to be 2. 2 is the only number that all of these divide. So we're going to have to take out a 2. So I'm going to write that down here. Taking out a 2. I'm going to have some other things going on. I just put an answer blank, otherwise I forget about it. So let's see. 20 divided by 2 is 10. Thank you. 10x squared. Negative 78 divided by 2 is negative 39. That gives me negative 39x. Thank you, sir. And a positive 28 divided by 2 is positive 14 times plus. What two numbers am I looking for? What is the product of A and C? A times C is 140, has to add up to negative 39. Well, that's going to be negative 4 and negative 35. Those are the two numbers that we're using. So I have 10x squared minus 4x minus 35x plus 14. And that lets me make two groupings. So what can I take out of the first parenthesis? Yeah, I can take a 2x out of the first. When I take that 2x out, I'm left with 5x minus 2. What can I take out of the second parenthesis? Yeah, I'm going to take out a negative 7. A negative 35 divided by a negative 7 gives me a positive 5. So there's my 5x. And 14 divided by negative 7 is negative 2. So that way I get my copycat. So copycat, 5x minus 2. What's left over? 2x minus 7. Okay. So we're going to fill out this little factoring chart just to remind you of the methods. And then we're probably just going to go right to the next page. I have these all worked out, so I'll scan them. But I'm going to fill out this little number 7, this little factoring chart. Okay. So when we are talking about factoring, if we just have one term, if we have one term only, we're just going to look for a GCF. That's all we can do, right? And here's my example. If I have 4x squared, actually, that doesn't even make any sense. Don't even write that down. Don't even write that down. You can't have one term. We're going to start with two terms. Two terms. So two terms, if we have two terms, you can look for a GCF. But really, you want to look for the difference of two squares. Do you guys remember that? The difference of two squares. So the difference of two squares is something like x squared minus 4. This is an example of difference of two squares. And when we factor that, here's how you think about that. What number made x squared? What did I multiply by itself to get x squared? Well, I took x times x. What number multiplied by itself gives me 4? 2. What do I put in the middle? What signs? Yeah, one gets a positive and one gets a negative. Another example of dots would be if you had a GCF with dots, difference of two squares, and I'm going to say 6x squared minus 54. So I can take out a 6 first for both of these. So I'm going to take my 6 out. And well, I'm going to write that over here. I'm going to take a 6 out. And when I do that, what do I have left? After I take a 6 out, I'm left with x squared minus 9, right? So how do we make x squared? Well, that's made by taking x times x. And what's the what number do I multiply by itself to get 9? 3. Remember we said we're just taking the square roots of those. So I have 6 times the quantity x minus 3 times the quantity x plus 3. So that's what happens when you have two terms. Okay. When you have three terms, you need to either use a factor box or hopefully the leading coefficient equals 1. And that means that the factors you choose are the factors. Anybody remember that? You use, right? When you have three terms. Okay. And then when you have four terms, you always factor by grouping. Okay, which is what we've been doing because I don't like the factor box. I even turned 3 terms into 4. Okay. I even turned 3 terms into 4. So when we first started this lesson on factoring, back when I taught you guys this, we're factoring trinomials, which are numbers that have a power of 2, which means that they're quadratics. So we said, hey, guess what? We're going to go from factoring to solving a quadratic equation. And so the way that we do that is we just take this trinomial and we set it equal to 0. We take the trinomial and we set it equal to 0. Do you guys remember what that was called? Anyone? Flip over to the next page, page 3. Are you good, Reese? That's fine. Number 4 is just grouping. 4 terms is just grouping. So this is the biggest part of our lesson. This is where we kind of took our whole factoring idea. So we took something like x squared minus 2x plus, I don't want to do plus, x squared minus 2x minus 8. And we said, hey, well, guess what? I know that this factors out to be x minus 4 times x plus 2. And we're going to take that and set it equal to 0. Because the zero product property says that if the product of 2 terms equals 0, then one of these has to equal 0. And that means we set it equal to 0. Either x minus 4 is 0 or x plus 2 is 0. And then we solved for x. So how am I going to get x all by itself here? I'm going to add 4 to both sides. And we find out that x equals 4. And on the next one, I subtract 2. And we find out that x equals negative 2. Well, this is a quadratic. This is a quadratic function. And what do quadratics graph into be? Do you guys remember? Quadratics graph into parabolas, right? So this is telling me that I'm going to cross the x-axis at positive 4, and I'm going to cross the y-axis at negative 2. This is my parabola. And this is negative 8. Do you guys remember that? We graphed them, okay? We graphed them all using Desmos, but we had to come up with the factors. So we're going to take a look at the factors and see if you can determine what the roots are. So when you solve for x, it's called the solution, but it's also called the root. It might be called the 0 or the x-intercept. Those are all of the names that we use to represent these two places on the y-axis. Sorry, on the x-axis. They're the roots. They're the solutions. They're the zeros. And they're the x-intercepts. So we're going to take that idea of factoring, and now we're going to set it equal to 0, and we're going to solve. Because we know that when y is 0, because this is no different than the equation x plus 3 times x minus 5 equals y. What we did is we replaced the y with a 0, because when y equals 0, that's where we cross the x-axis. So that's what this whole idea is. And we spent a lot of time on solving. So we're going to take each one of these factors right here, and we're going to solve it and try and sketch a graph. We're just going to make a sketch. So either this equals 0 or this equals 0. And we solve for x. So hopefully you notice that when we solve for x, you should be writing this down. When I subtract 3 from both sides, if I have a factor of x plus 3, my solution is negative. If I have a factor of something minus, if my factor is x minus a number, yeah, my root or my solution is positive. So we came up to this whole idea that said the roots, this is like a little asterisk, the roots are the opposite of the factor, meaning that the roots have the opposite sign of the factor. So if the factor is x plus 3, the opposite of a positive 3 is negative 3. So x is going to equal negative 3. If the roots are x minus 5, or if the factor is x minus 5, then the root is positive 5. So I'm just going to sketch this graph so you guys kind of are with my brain on the whole factoring thing. So what are the two places that this crosses the x-axis? Yeah, positive 5. 1, 2, 3, 4, 5. And at negative 3. 1, 2, 3. Okay. So we learned some things about if the leading coefficient is positive, it opens upwards. And we also learned that when you take these two numbers and multiply them together, that gives you your y-intercept. So this is actually crossing the y-axis at negative 15. This is something like that. It's just a sketch, but that's what these are. These are the roots. This tells us where our parabola crosses the x-axis, and that's important, right? That's important. Unfortunately, your roots are not always nice whole numbers or integers. Unfortunately, sometimes your roots are fractions or decimals that go on forever, right? So let's look at number 2 and try and figure out what the roots are for number 2. So to start off, I have to say that 2a plus 4 equals 0 or a plus 7 equals 0. So I have to solve for a for both of these. I have to get a all by itself. So what do you think? Yep, subtract 4 from both sides. I agree. So 2a equals negative 4. Yeah, we're going to divide both sides by 2. So a equals negative 2. Or what about the next one? Sorry, a equals negative 7. Yes. And minus 7. A equals negative 7. So tell me why this did not end up in a fraction. Why did that first one not end up in a fraction? Yeah, there's a common factor of 2 in there. You're exactly right. Common factor of 2. So where is this going to cross? What two places are these going to cross where are these going to cross the x-axis? At negative 7 and negative 2. Okay. Nope. I just want to get your brains thinking. So my sketch is going to look something like this. And this right here would be the number 28. Okay. That's what these look like. That's what this is like. That's what these tell us. These tell us these roots or solutions just tell us where we're crossing the x-axis. That's really important. Okay. Number 3. Yeah, 4 times 7 is 28, right? Remember I said that these two numbers, when you multiply them together, give you your y-intercept? Yep. So let's do number 3. So 3t plus 5 equals 0, or t minus 3 equals 0. So how am I going to get the first one all by itself? How do I get t all by itself? First, I'm going to subtract 5 from both sides. So 3t equals negative 5. Then I'm going to divide both sides by 3. So I find out t equals negative 5/3. That's definitely a fraction. For the second one, I'm just going to add 3 to both sides. Sir? Perfect. T equals 3. So I'm going to, again, sketch the graph. You guys do not have to do that. You don't have to sketch the graph. I just want you to see what's happening here. I have a positive 5 and a negative 3. So my y-intercept is going to be negative 15. So this is where I'm going to cross the y-axis at negative 15. And my roots are positive 1, 2, 3. And negative 1, negative 1, negative 2, because negative 5/3 is the same thing as negative 1 and 2/3. So it's going to be about right here. This is where negative 5/3 lives. So my graph is going to look something like this. Okay. Do you guys remember doing that? Is that okay as a review for you? Okay, flip it over to the back side. So for the back side, we're going to use a calculator. We're going to use Desmos. So for the back side, we're going to do everything in Desmos, because I want you to remember that this is really how we did this, right? We used Desmos graphing for these. So I'm going to clear my Desmos screen, and we're going to plug some stuff into our computer. Okay. So, and then I'll use the y equals. I'll show you on a calculator as well, but I just want to show you. So for the first one, number 1, the steps say set it equal to 0, factor the equation using whatever method you choose, set each part equal to 0, and solve. Well, remember that you can actually just have Desmos solve it for you, right? So I'm just going to type in y equals x squared minus 11x. Okay, and I'm going to show you that there are 2 places where my graph crosses. Yes.
Are these type of problems that we wouldn't have a calculator?
You might not have a calculator for a basic one like this, but probably you will. Like for anything that has a coefficient other than 1, you will have.
Whenever you have a calculator, will you also do Desmos?
Yes, the Desmos graphing is embedded into your test. Okay, yep. So where are the 2 places that this crosses the x-axis? Well, the first one is right here. That's the point x equals 0. And what's the next one? 11. X equals 11. Well, let's see where those came from. When I look at this function, I only have a GCF. X times the quantity x minus 11 equals 0. Hang on, just let me get through this and then I'll answer your question. So when I look at that, I'm factoring this out. I'm looking for my cursor. So it means that either x equals 0 or x minus 11 equals 0. Well, x equals 0. That's the factor that we got right here. And if I add 11 to both sides, that's where I get the other answer. X equals 11 right there. It was 11. I erased it when I moved it over. So those are your 2 points, 11 and 0. So you can use the Desmos graphing calculator for that. No, that's totally fine. Thank you so much for taking care of that. I appreciate it. Zach, I'll print these off for you. Okay, bud? So there we go. So let's try another one. Number 6. So can you guys look at number 6? Do you think there's a GCF in there? What is it? 8. Yeah, 8b. I can take an 8b out of both of them. So that would give me 8b times the quantity b minus 5 equals 0. So either 8b equals 0 or b minus 5 equals 0. Let's see what that turns into be. So I'm going to go back to the equation that I already have started, and I'm just going to put an 8 in front of that. 8x squared minus 40x. So it says that my roots are 0 and 5. My roots are 0 and 5. Well, let's see. When I divide both sides by 8, I definitely get that b equals 0. And when I add 5 to both sides, I definitely get what? That equals 5, yeah. So you can use Desmos or your calculator to solve. You can use Desmos or your calculator to solve. Okay. I want to do number 7 and number 8 because they look different. They look different than what we've been doing, and I want to show you both ways that you can solve those because they're still quadratics. They're still quadratics. Okay. So for number 7, I want you guys to look at that. How is number 7 different than what we've been doing? What's step number 1 or step number A say up under the directions, solving a quadratic? Yeah, is this equal to 0? No, I can't solve this unless I set this equal to 0. So how do I do that? Yeah, I have to set it equal to 0. So set equal to 0. That's super important. So I'm going to subtract 3c from both sides. So c squared minus 3c equals 0. Then I can divide both sides by c. So I have c times the quantity c minus 3 equals 0, which means that either c equals 0 or c minus 3 equals 0. I'm going to put that into my Desmos, and let's graph that. X squared minus 3x. And let's see, my roots are 0 and 3. And that makes sense because when I add 3 to both sides, I'm going to get that c equals 3. And we already know that c equals 0. So do you see how we're using Desmos to check our solutions? You're just going to plug the equation into Desmos, and the solution is where the parabola crosses the x-axis. Yeah. The solution is always where the parabola crosses the x-axis. So for number 8, what would you do for number 8 to solve that? Yeah, add 10x to both sides. Do that. Add 10x to both sides. So when I do that, I end up with x squared plus 10x equals 0. And I can just take out an x. I have a GCF of x there. So that's going to give me x times the quantity of x plus 10 equals 0. So that means that either x equals 0 or x plus 10 equals 0. And if we have a positive factor, we know that our solution or our root is going to be negative. Let's check. X squared plus 10x. So I have 0 and I have negative 10. 0 and negative 10. Okay. So I'm going to freeze and stop our video.